You're going to be doing a bit of independent work now, and you're going to be looking at these decimal numbers and thinking about how I would make them up out of tenths. So you're going to be thinking about 3.4 metres and thinking, in 3.4 metres, how many tenths of a metre are there? And if you want to write it as a fraction as well, fantastic. Then you've got some to do the other way as well. And there's a good star challenge that I think will keep you busy if you whiz through these ones quickly. So everyone turn back to your books and we're doing the next bit of independent work.
And then what does the 4 represent?
How many tenths there are? 31.6 times 0.1. This one is... No. This one's wrong. Yeah, that's wrong.
There's 30 tenths in 3 metres. In the tenths, there's 4 tenths. So it must be 34.
So 4.9 metres is...
49 tenths.
Fantastic, Piran, it is.
And then 40.
Great. Fantastic. Good. Now, Charlie, you're getting on to thinking about this one, aren't you? Thinking about the star challenge. So, should we have a look at that one together?
Yeah.
So, he's used his deans to represent a quantity. So, what number has he represented with his deans?
3.1.
He has. Why don't we write that underneath? Because that's going to really help us. Okay. Now, Sam's thought of lots of different ways of writing things that he thinks are equivalent to 3.1. So let's go through them all and let's think about, are they right or not? So which one would you like to start with?
I don't think that's right because it has to be a plus, not a take away.
Fantastic. So give him a cross for that one. He's got that one wrong. And you write out what you think he should have written for that one. Challenge for the high retainers comes in the form of what we call the star challenges. I wanted those children to really be able to think about many, many different ways of representing a decimal number with symbols. Brilliant, okay. Which one should we look at next?
This one. This is wrong because that should be there and that should be 0.1. So.
Okay, fantastic. So rewrite that. Right, which one should we look at next, do you think, Charlie?
Those two would be 3 and then, so he's right there.
Great. So what does this, will you read it out to me out loud, this one?
40 tenths, take away 9 tenths would be 31 tenths, so that one's right. So.
Well done, Charlie. That's great. It was a good challenge for him and he had to slow down and think and slow down and take his time to do that in a way that he actually probably hadn't had to do in the first part of the activity. He moved through that pretty quickly. And I guess that's what I'm aiming for with the STAR Challenge, is to get those children that have raced through work quickly or have picked up concepts quite quickly to slow down, stop, think and make connections. Right, what about this one? Can you help me look at this one and understand what he's written in here?
So 30 times 1 would be 3, and then 1 times, so that one's right as well.
Just go through this one again. So, convince me that 30 times 0.1, 30 times 1/10 is 3. Yeah. Why is that?
Because 30 of these would be, 10 of these would be 1, and then you have 2 more 10s left, so that'll be 3, and then over here 1 times that would be this number, so it's right, I think.
You're absolutely right. Right, we're going to go through these now. So let's start with the first one, 3.4 metres. Who can tell me how many tenths of a metre there are in 3.4 metres? Eli?
34.
Good. There are 34 tenths of a metre. Can you say that, Eli?
There are 34 tenths of a metre.
34 multiplied by 0.1. Did you write that as a fraction as well? Anyone right there who wrote that as a fraction? Altia, how do I write it as a fraction?
34/10.
Good, 34 tenths. My numerator is 34 and my denominator is 10. Fantastic. Okay, 4.9 metres, the next one. Who has worked out how many tenths of a metre there are in 4.9 metres? Let's go to Isabel.
There are 49 tenths in
our quantity there?
1.9.
In 4.9. There are 49 tenths in 4.9. Okay. How do I finish that number sentence? 49 times what, Isabel? 49 times?
1/10.
Good. And 1/10 I write as 0.1. And that's equivalent to 49 tenths of a metre. Okay, what about 0.5?
0.5 is equivalent to 5/10.
Good. 5 times?
0.1.
Thank you very much, Tegan. And that's equivalent to 5 tenths. What about these ones? Could anyone do it backwards? If I have 16 tenths of a litre, 16 tenths of a litre, does anyone work out how many litres I have? And can you explain why? Let's go to Sian at the back.
Well, there's 16. Well, there's 0.16 litres.
0.16. Let's have a look at that here. Yeah, this? Okay, fantastic. Let's all have a look at this together. What does the 1 represent?
It represents that there is.
Right, Janelle, what did you tell us about where the tenths sit?
The tenths are on the right-hand side of the decimal point.
Fantastic. So what does this 1 represent?
1/10.
It does. That 1 represents 1/10. The 6 represents something called 600ths that we've not done yet. So, Sian, we need to just think again about that. Because if we've got 16 lots of a tenth, we can't also have 1/10. What do we know, Rakeen, about 10 tenths?
10 tenths are the. Oh, I forgot the word.
Equivalent.
Equivalent to 1 whole.
Fantastic. So, Sian, let's have a look at this, darling. My 16 tenths is made up of 10 tenths, yeah, and 6 tenths. What do we know about 10 tenths?
That it's equivalent to 1 whole.
Good girl. And how many more tenths have I got?
6.
Good girl. So, Sian, this is how we write it. 1.6 litres. Okay? What does the 1 represent?
That there's 1 whole.
Good girl, Sian. What does the 6 represent?
That there's 6 tenths.
Good. And 1 whole and 6 tenths is 10 tenths and 6 tenths, which is 16 tenths. Really well worked through, Sian. I'm really proud of you. Well done. What about the next one? 28 multiplied by 0.1 kilograms, 28 tenths of a kilogram. Thomas, can you answer that one for me and explain why?
There are 2.8 kilograms because there are 10 tenths in 1 whole, and there are 2 whole, and there are 20 tenths.
Good.
And then there are 8 tenths, so it's 2.8.
Good. So I've got 20 tenths there and 8 tenths there. That's fantastic. And what about the very last one? 31 multiplied by 0.1. 31 lots of 1/10.
It's 3.1.
What does the 3 represent, Rishi?
3 wholes.
And what does the 1 represent?
1/10.
And can you convince me, Rishi, that 31 multiplied by 1/10 is equivalent to 3.1?
Wait. 31 is equivalent to 3.1 because there is 3 10/10ths and there is 1/10.
That's a really fantastic explanation, Rishi. There are 3 lots of 10 tenths and 1 more tenth.